Today is going to be the second day on 8.4, sine, cosine, and tangent. So you're going to be trigonometric ratios to find angle measures. So yesterday you were doing sides, now you're going to find the angles. So just a little background knowledge with this. When you're doing these angles, you're using something called the inverse sine, inverse cosine, inverse tangent. So you've actually already done some of that with algebra. So think of it as, just for an example, say you have to solve this problem, okay, in algebra. So what you would do is you would take, you could either divide both sides by 2/3, or you could multiply by the reciprocal. This reciprocal, to get x alone, is called a multiplicative inverse. What happens is that 3 halves times 2/3 gives you a 1 in front of x. So when you're solving it, you can get that x alone. So that's a multiplicative inverse. It like undoes an operation, an inverse does. So when we do inverse sine, inverse cosine, inverse tangent, what an inverse sine does is it undoes the sine function. The cosine inverse, the inverse cosine, undoes a cosine operation, and an inverse tangent undoes a tangent. So let's do some examples. We're going to use the acronym SOHCAHTOA to help us out. So just like yesterday, it's still always all about the angle. Okay, so in relation to the angle, you have to decide whether to use sine, cosine, or tangent. And usually that's the hardest part. So notice that 6.5 is on the opposite side. So we're either between sine or tangent. And then we also have a hypotenuse. So we're narrowing it down to using sine. So the way you set it up is you take sine of angle x equals opposite over hypotenuse. So opposite is 6.5, and then hypotenuse is 10. So we need to get x alone. Okay. Now there's no such thing as dividing by sin. Like it doesn't. It's a function, so you need to use the inverse of that function to get x alone. So I'm just going to write this over so you can kind of see what's going to be going on here. But ultimately what we're doing is we're going to take the inverse sine of both sides, and that's what this looks like. So I'm taking the inverse sine of both sides of the equation, and I'm not going to get x alone. So the inverse sine of sine gets your x alone. Just like when we did fractions, the inverse of the fraction, the multiplicative inverse, got my x alone. So what I'm left with then is this inverse sine of 6.5 over 10. Now you're just going to type that into your calculator. So the way you do that is you're going to hit the second button. Now this is for the calculator most people have. I'll show you both of them today in class. But you're going to hit second sine. Okay, and that you should see on your calculator that inverse symbol, that exponent of -1 with inverse in your calculator, and then all you're going to do is type 6.5, hit the division sign, 10, and then enter. Okay. And when you type that in, you get about 40.5, so round to the 10th of degree when you're typing that in. Hey, next one. Here we go. We have an angle. We're unsure about the angle, which trig ratio to use. Notice that 9 is opposite of x. So I'm between sine and tangent again, because those ones both have O. And then I have my adjacent leg is 3. So I'm going to be using tangent. So tangent of x of the angle equals opposite. So 9 over adjacent 3. So again, to get x alone, I need to take the inverse tangent of both sides. So the way that looks is I'm going to take the inverse tangent of the tangent of x and the inverse tangent of 9/3. By doing that, you get your x alone, and what you type in your calculator is now second tangent 9 over 3. So if I go second tangent 9 over 3, what I get for my answer is 71.6 about. Again, you got to figure out, here's my angle. What trig ratio should I use? Across from that angle, aka opposite, is 4. So I know I'm between sine and tangent again. And my 5 is on my adjacent leg. So I'm going to be using tangent again. So I'm going to do the tangent of x equals opposite over adjacent. So 4/5. And again, what I'm going to be doing is the inverse tangent of both sides. So I'm doing the inverse tangent to the left side, that way my x is alone, and then I'm going to do the inverse tangent of 4/5. So I'm left with x equals inverse tangent of 4/5. And what I get for that is 38.7 degrees above when I do that. So the inverse, you have to do an angle every time. Whereas like the regular tangent of an angle gives you like a ratio of the sides. Here we go again, number 4. Here's your angle. Now you have to figure out, am I using sine, cosine, or tangent? Well, 8 is on an adjacent leg, so I know I'm between cosine and tangent. And 18 is my hypotenuse, so I'm going to be using cosine. So I'm going to be doing the cosine of x equals adjacent over hypotenuse, of your 8. And then to get x alone, I'm again going to do my inverse cosine of both sides. Because that's what undoes that cosine operation here. So the inverse cosine or cosine, they undo each other, so I'm left with x alone. And what I'm going to type in my calculator is the inverse cosine of 8 divided by 18. So I get about 63.6 degrees. Number 5, here's my angle. I have to figure out whether to use sine, cosine, or tangent. 8 is opposite the angle, so I'm between sine and tangent. And 10 is adjacent to my angle, so I'm going to be using tangent. So the tangent of x, the angle, is opposite over adjacent, so 8 over 10. And same thing again, I'm going to do the inverse tangent of both sides, because I need to get that x alone. And to undo a function operation, I need to do the inverse of both sides. That's what an inverse does. So what I'm going to type in my calculator is the inverse tangent of 8 divided by 10 equals, and I get 38.7 degrees. Couple more. Here's my angle. I gotta use decide between sine, cosine, tangent. 10 in relation to my angle is adjacent, so I'm between cosine and tangent. And 27 is the hypotenuse because it's across from the right angle, so I'm going to be using cosine. So the cosine of the angle is adjacent 10 over hypotenuse 27. Same thing again, I need x alone, so I need to do the inverse operation. So the inverse operation of doing the cosine of something is doing the inverse cosine. So what these do is these cancel out, and I'm left with the inverse cosine of 10 over 27. So second cosine, 10 divided by 27, and my x then is 68.3 degrees. And then my last one. Here's my angle. I have to decide if I'm using sine, cosine, tangent. 13 in relation to my angle is adjacent, so I'm between tangent and cosine again. 19 is the hypotenuse, so I'm going to be using cosine. So cosine of x equals adjacent over hypotenuse. And again, to get that x alone, I have to do the inverse operation to both sides, which is my inverse cosine. Taking the inverse cosine of cosine gets my x alone, and what I type in my calculator is inverse cosine of 13 divided by 19. So 46.8 degrees rounding to the 10th, and then that's it.